Have you ever wondered what the most menacing vulnerabilities are in the world of web applications? Today, we'll decode the OWASP Top 10, your roadmap to the digital danger zones. The OWASP, or the Open Web Application Security Project, is our guide. They spotlight the biggest web application security risks. It's a nonprofit organization dedicated to improving software security. Think of the OWASP as one of the foremost authorities when it comes to web application vulnerabilities. It's important to note the OWASP Top 10 isn't updated annually. While the OWASP has other projects and tools that receive regular updates, the Top 10 list is updated based on the evolving threat landscape, roughly every 3 to 4 years. By understanding the most common vulnerabilities, like those of the OWASP Top 10, you're better equipped to prevent and address them. Let's take a look at the OWASP Top 10 website to quickly review these attacks, and then I'll break each one down for you. Let's go ahead and head over to OWASP www Project Top 10. Notice as we come to the top, we just see the OWASP Top 10. If we go ahead and head on down, scrolling down, we can see the top 10 web application security risks. Notice they have it for 2017 over here on the left, and then 2021 on the right. These green arrows that you see in between these, it's actually going to tell you which ones have moved up as well as which ones have actually moved down. This is because every year these attacks, they go in waves of how popular they are. Some years they become more popular. Other years they become less popular, all the way to the point that they may even be removed from the list altogether. So let's go ahead and go over what the top 10 vulnerabilities are for 2021. We're going to be talking about broken access control, cryptographic failures, injection, insecure design, security misconfiguration, vulnerable and outdated components, identification and authentication failures, software and data integrity failures, security logging and monitoring failures, server-side request forgery. First, let's talk about broken access control. Like a bouncer letting in the wrong crowd, flawed access control can allow unauthorized actions within an app. Let's go ahead and see the number one for 2021. As you look at broken access control, we'll see an overview of it along with a description. More importantly, we'll also see the different ways that you can actually prevent it. Each one of the categories inside of the OWASP Top 10 will have all of these different elements, not only explaining to you what the vulnerability is and how it's exploited, but also what you can do to prevent it. To avoid broken access control, it's important to automate vulnerability testing when developing code. Otherwise, an account may accidentally be given access rights outside of the scope of its role. The next one, cryptographic failure, is going to be number 2 on the list. Cryptographic failure, previously called sensitive data exposure, is like leaving our laptop open with your company's private information on the screen while you go and order a coffee. Someone could just walk by and see all of that sensitive information. And if that person is a hacker, they could easily steal the data and use it to their advantage. Some apps accidentally expose sensitive data, making it a gold mine for hackers. It's like having your password on a Post-it note stuck to the locked computer screen. Let's talk about injection attacks. Imagine you're standing at your door, ready to unlock it, except instead of pulling out your house key, you grab a car key. But to your surprise, the door still opens. Injection flaws are like opening the door with the wrong key. These attacks let hackers send malicious data to an app, which can trick it into doing something harmful. Essentially, it lets hackers in the app without having permission to do so. Once they're in, that's when they can really wreak havoc. Cross-site scripting, which used to be its own category in the top 10, has been folded into this broader injection attack category. With cross-site scripting, attackers can slip malicious scripts into web pages, which can then run on a user's browser. It's like a Trojan horse hiding in plain sight. Next, let's go over to insecure design. This one is new on the OWASP Top 10 list. This vulnerability has to do with flaws in the design of a web application. If that sounds broad, it's because it is. Design flaws have more to do with the initial design rather than the implementation of the code, which is considered a different root cause by the OWASP. This could be unintentionally creating backdoors open in your code so that hackers can sneak in and wreak havoc. It could also mean not testing your code thoroughly enough during creation and introducing vulnerabilities. It could even include not considering all the business risk while designing the software or the system. Let's go ahead and look at security misconfigurations. Security misconfigurations, previously called XML external entities, are a way for attackers to take advantage of poorly monitored or misconfigured security infrastructure. For example, leaving factory default settings on a device. If apps aren't set up securely from the start, then they're sitting ducks for attacks. The web application stack is like a 7-layer chocolate cake, encompassing a network, web server, application server, and database with the framework that surrounds it. At each layer, you can have default configurations, incomplete setups, exposed error messages, or overly permissive permissions, or accidental services accessed. Some apps can be tricked into fetching these files for attackers. This is the problem with security misconfigurations. Next, let's go ahead and head on over to vulnerable and outdated components. Vulnerable and outdated components pose a significant threat because attackers can exploit these weak spots. Using outdated or vulnerable software components is like building your house with weak bricks. It's important to make sure you know all the versions and components of your web application development, and make sure that the versions are updated often as patches come out. If the components get too out of date, you'll need to look at replacing it with a newer option that's better supported. Next, let's go over identification and authentication failures, previously called broken authentication. In this case, it's kind of like a thief sneaking into a secure location by dressing up like a security guard with a fake badge. Technically, they look the part. Yes, they're really not authorized to get in the building. Apps can similarly be tricked. They might ask, "Who are you?" But if you're not thorough, an imposter can sneak in. This flaw lets attackers pretend they're someone they're not. Next is software and data integrity failures. Let's go ahead and head on over there. Software and data integrity failures, which includes the previous category of insecure deserialization, at the root of software and data integrity failures is something we all do every day, usually with poor outcomes. We make assumptions. When developers make assumptions, it can lead to vulnerabilities in the code. That can look like assuming a piece of software was updated or assume a web app is gone through the proper CI/CD process. But if someone isn't verifying these steps somewhere, there could be a problem. Before we can understand deserialization, it helps to understand what serialization is. This is when some kind of object is converted into a data format for easy storage. Deserialization, on the other hand, is putting the data back together to make the original object. Insecure deserialization happens when vulnerabilities are introduced while converting data back into the original object. Attackers can then manipulate the code to execute malicious commands. Next is security logging and monitoring failures. If an app doesn't keep track of suspicious activities or is slow to detect breaches, it's akin to ignoring alarm bells. Prompt response is crucial. And last on the list is server-side request forgery. Let's go ahead and head on in there. This is where an attacker specially crafts a URL request to a server that doesn't validate the incoming code from the client. Because of this vulnerability, the server can be used as a proxy to forward requests containing executable code from the malicious user. What kinds of code requests might be forwarded? Well, think of an attacker using an unsuspecting server to forward requests to check open or available ports on the server's local network, or having the targeted server execute code requesting file path information from the client for local file traversal attacks, or access to local services on ports to set up a remote connection. Server-side request forgery can also be used to have the target server forward URL requests to other cloud-based servers to fetch tools for remote exploitation. Although SSRF is a new addition to the top 10, it's quickly becoming one of the more widely exploited vulnerabilities on the list. Expect to see it move up in the next edition of the top 10. And there you have it, the latest OWASP top 10. Remember, understanding vulnerabilities is the first step to building safer digital realms. Knowledge is your shield and armor in the digital world. Stay informed, stay vigilant, and keep those web apps secure.